All right, Sean, as you know, I'm a very, very busy man, very important.
What I don't know about that.
Yeah, no, I don't know about that. But, you know, we have lots of things to do these days. And I thought, well, wouldn't it be nice if instead of having to record lots of videos, I could just completely replace myself with artificial intelligence and then go off for a nap. That's my goal. So, you know, just for fun, we thought we'd see if we can create a video in 2025 of an AI Mike Pound doing a computer file. Right? Now, it probably won't work. It might work a bit. Who knows? Right? Let's see. But the idea would be that, you know, we can start shipping out AI videos and then we can go off. We thought what we would do to make it a bit more interesting is we just see what we could do with open source tools running on desktop hardware. So we're trying to avoid, you know, hugely expensive cloud services. And, you know, let's see what happens.
Thanks, Human Mike. I'll take it from here. Hi, everyone. I am MikeBot. I don't need to eat, sleep, and I can generate short Computerphile videos about any topic. And today, the inferior Human Mike and Lewis will be explaining how I was created.
There is a serious reason why we're doing this. The progress in AI has been very, very fast. There's lots and lots of stuff in the media about, you know, fake news and fake image generation, deepfakes, and all these different kinds of technologies. And they are going to get to a point, if not today, then soon, where they can become quite convincing, and we need to think about that. So we're mostly messing around, but also just seeing what works, what doesn't work, right? Now, I'm actually not the expert in all these different tools, so I brought in Lewis here, who actually does a lot of generative AI for his PhD. And so, you know, Lewis has built a pipeline that I think you've called MikeBot.
MikeBot3000.
MikeBot 3000, okay. I mean, I might have given it a slightly different name, but fine. And so Lewis can, you know, outline what he created with only open source stuff, right?
Yes, running on my computer at home, which is a 4070 Super, which is a good graphics card, but it's not top of the range. It's only got 12 gigs of VRAM, which for AI models isn't that much actually. And we've only taken 20 images of Mike to make this, right? And that's to make a point of how scary this technology is getting. 20 images.
Is that 20 photos or 20 sets of videos?
20 photos from different Computerphile videos. So it'll be Mike like that, one like that, you know, him. And I've sort of chosen these to, you know, pick a range, right? And I've got some audio as well. This will work with 10 seconds of audio, but it won't be very convincing, right? But we've taken an hour now of Mike and retrained it to be really, really nice.
So, I mean, I should add that I actually gave permission for this, right? So that's okay. But actually finding that many pictures of someone is not a big deal, right? Most people are uploading these things to Instagram or some other kind of website. So, you know, if it's possible with me, it's possible with anyone. And that's kind of something to think about.
Yes. Right. Yeah.
So what's the pipeline?
Basically, MikeBot, as we said, it's all open source. So you can use this yourself, right? But you start off with a prompt. So we want MikeBot to be as, you know, simple for the user as possible. They just go, tell me about this. MikeBot creates a 30-second video, right? Dead simple. So I'll start off with a prompt, right? And that could be, tell me how an AND gate works or something like that, right? So then that goes to an LLM, Chat-GPT, Llama, DeepSeek, that sort of thing, right? So it goes to an LLM, and the LLM goes, right, I'm going to create a script here. And that in a script, there's a scene, and in each scene, there's an image prompt, a video prompt, some audio, and whether Mike's in the camera or not, right? So for each image prompt, that gets sent to an image generator. And in this case, we use Flux, which is an open source image generator, and it's extremely good. We'll go into more detail about all this. I'm just going to draw the pipeline for now. Then the script goes to a text-to-speech, and this is called T5 TTS. Also very, very good. I think this is as good as the closed source stuff. This model is very nice. What we do is we take the length of how long Mike is speaking for, and then we pass that and the image into a video generator. In this case, we've used WAN. And the thing is with WAN, and this is the case of all video generators at the moment, which are open source, they can only generate a certain number of seconds. So what we do to make it the length of the dialogue is we will generate X number of seconds, and if we need to generate more, we take the last frame of that video and have it as input to the next video. I'll go over why that doesn't quite work later, but I couldn't figure out a better way of doing it. So that's basically what I've done, right? So now, for each scene, we have a video and we have audio. If Mike is in the frame, Mike is not going to be matching the audio, right? So what we do is we pass this and that into a lip syncing model, which is latent sync. And what that does is matches Mike's lips to the audio. So now you've got Mike talking with dialogue, right? And then what we do, final little thing. Oh no, I've run out of space.
That's the story of my life on these videos.
Oh dear. We just do some post-processing where we frame interpolate and we upscale. So suddenly it's a HD video of Mike and it looks smooth. So we do all that, we do it for each scene, combine all the scenes together and you have a video, right?
Why did you choose these particular tools for this?
Well, we can go over that now, all right? How they work?
Okay.
Yeah, cool. So Flux is state-of-the-art image. I think it's very, very good. So it uses diffusion to generate an image based on a text prompt. I think you're the man.
We've actually done a video on diffusion, but if as a very quick recap, if you remember, what diffusion does, which is kind of interesting, and why it's sort of taken over the landscape of image generation, it starts with a completely noisy image and has been trained to slowly remove that noise into a nice looking image. And it just seems to be very, very good at following prompts and producing aesthetically pleasing images, right? Particularly if you can tweak it through training.
Yeah. One thing I've realised, I forgot to add, is a LoRA here of Mike, right? And so, what is a LoRA?
All right, well, so maybe a LoRA in detail would be a really interesting topic for another video. But essentially, one of the problems you have with these giant image generators, because they've been trained in such a general way, is that they produce lovely pictures of castles and clouds and fairies and things. But if you say draw Mike, they're just going to produce a picture of a person, right? They don't know which Mike you're talking about, right? They have no concept of me, right? I'm hopefully not too much in the training set, but we'll see. What a LoRA does is retrain one of these networks into a specific style or for a specific token like my name, so it knows what I am. The problem is that these are huge, huge models. And so, you're running this on what you say, a 12 gigabyte card.
Yeah, no chance.
Yeah, so what a LoRA does is it sits on top of the model and is a mechanism for training just a few of the parameters. In actual fact, what you do is you train a couple of very small low-ranked matrices that look like this, where this is your rank here, and they multiply together to create the full rank of the original model. So you're training a sort of simple version of the network over the top. And the nice thing is, this is very good at refining a model to do a certain concept without completely wrecking the rest of the capability of the model. It can still draw castles, it can just put me in them as slightly better than it could before.
Yeah, and the good thing about a LoRA is that you don't need that many images of the thing you're trying to copy, right? So for Mike LoRA, it was only 20 images and then just a prompt saying what's happening in that image, right? So it'll be Michael Pound, and these are all taken from Computerphile videos. So it was Michael Pound in an office, he's wearing a black shirt and he's looking happy.
Some sort of t-shirt or jumper, as always.
Yeah, and he's got a little mic on here as well.
Does it stand for anything, LoRA?
Yeah, LoRA stands for low rank adaptation. So we're adapting this network using these low rank matrices, basically. Really interesting thing. We've used quite a few times in various bits of work.
Now that we've got this LoRA, we can generate Mike doing anything we want, which is, both fun and quite scary, right, for you. So I've gone away and made some images of Mike doing some various things. And I thought that'd be quite fun to show you what you can do with a LoRA and Flux.
So let's talk about the video generation. Now, is there a reason you've drawn your end backwards?
I'm an idiot. Essentially.
These things happen.
Yeah.
Sean will edit that out of the video for sure.
Cool. So I've realised one more thing. We've actually got to pass in the video prompts as well.
Oh, yes.
Into this. So what these video models do is they basically do diffusion in 3D. So rather than diffusing over one image, you're diffusing over a series of images, which are the frames in your video. I don't have time to go over how these models work, but potentially follow-on video.
That's a very interesting follow-on video.
They're very, very interesting. So what it takes from here is it takes the image that you generated from Flux of Mike or a diagram or whatever, and a text prompt that's generated from the LLM going, let's say, Mike explaining something or Mike, hand over the diagram or something like that. And then it generates a video. But that video is only 4 seconds. I can only get 4 seconds on my graphics card. So I take the last frame and do it again. In a couple months, they will have fixed it. You know, there'll be a better way of doing it, but that's the way I did it. So you can then generate a series of videos.
At this point, the videos sort of look like me. They sort of adhere to what the LLM was asking for.
Yeah.
And you've got audio.
Yeah.
Oh, we haven't talked about audio yet.
talked
Okay,
about
let's
audio.
talk about that next then. The LLM's produced a script that needs to be read out.
Yes.
Right? You've trained this on some examples of my speech.
Yep.
Right? And what this is essentially doing is this is another diffusion process, but this time in audio. It's very common in the literature, rather than try and generate an audio waveform as you might think of it, you know, with just kind of a single line, is to generate that same thing over time. And you can imagine that if you plot that over time, you actually get an image, right, of what the audio is doing over time, a spectrogram. And it's these things that these diffusion models generate, right? It's very effective that way, and it allows you to generate sequences of audio waveforms, which is, of course, what speech is.
For the input, you also input 10 seconds of audio of Mike speaking and then what he said. And then when it denoises it, it includes that initial flow of Mike speaking. And so it tries to match what Mike has said before. So these models can work with 10 seconds of audio of someone speaking. Now, your output's going to be very varied on how good it is. Sometimes it will nail it, sometimes not so much. So what we do is we retrain the diffusion network basically to better have, copy what Mike is saying, basically, how Mike speaks. We do that with about an hour of Mike talking, which was a bugger to edit down because every background noise, every time Sean speaks, has to be removed. It's just pure Mike speaking.
Sorry, I had to go through that.
Yeah, it's all right, worth it.
So that obviously is going to capture things like is it called the timbre of Mike's voice and perhaps some of the intonation and the pitch and all that sort of stuff. But it's obviously not necessarily capturing how he talks, how he sort of phrases things.
Yes. So I would say, which you'll hopefully hear in a minute, is that it sounds a lot like Mike, but this is going to sound really corny, but I don't think it has Mike's soul, if that makes sense. The way Mike will say certain words.
It can't be replaced. That's the thing,
There you
right?
go.
It cannot be done.
Yeah. The tempo, I'd say.
And presumably also, even in a couple of hours, not every word is going to get said, right?
Yeah.
I'm going to say the same word "the" a lot of times.
Whistle-stop tour of the rest of this stuff. Latent sync. For the videos with Mike speaking, his lips need to match the audio, so we use latent sync for that. Very, very good model, in my opinion. It works fantastic. And then we post-process it, so we do frame interpolation and we upscale it to make it look like a proper HD video that Sean would capture on his nice camera. These models are getting easier and easier to use, right? You don't have to program any of this yourself. MikeBot really is just chaining these different systems together. It's very script kiddie, energy, right? I'm not doing anything really clever here. So what that means is that the easier these are to use, the more people are going to use them. Which is why you're seeing more and more AI.
And that's both good and bad, I suppose, right? So on the one hand, it's good that people get access to these tools. On the other hand, of course, it means that people could use them for, less altruistic purposes.
Yes. If you want to do this yourself, I've included a link with more information about all this stuff on my GitHub.
So should we have a look at the results?
Yes, I've been waiting like a month to show you this. So we've got a laptop in front of me where I have all the images that I've generated of Mike. So I thought it'd be funny to go through them and we can have a look at what sort of stuff you can generate with 20 images, 20 starting images of Mike. So we have skydiving Mike,
Very nice.
jungle Mike, night Mike,
I like that one.
Candyland Mike,
So. That's deeply concerning.
Superman Mike.
Nice.
I don't know what's going on with the cat.
It's actually a cat table.
It's a cat table, and it's giving you. I think it's giving you 6 fingers on the right hand.
Oh, that happens.
Yeah, that's normal with AI. We've got Michael Pond.
I'm glad you've been getting on with your PhD. Lewis.
Mike on a bike.
Yeah.
A bike on a mic. Mike at a strike.
Nice.
Mike on a bike at a strike. A bike on a mic at a strike.
I'm surprised it could produce that kind of nuance, actually.
It's really impressive. It's got the sign is correct.
Yeah.
Mike's on the floor. And for some reason, it's giving you a Nike t-shirt, which I didn't tell it to do. So I don't know whether that's...
I don't think I've ever worn a Nike t-shirt on camera. I don't think I own a Nike t-shirt. No disrespect to Nike.
No, that's the rhyming though.
I think it has done that. I think in the latent space.
Mike on a bike on a... Yeah.
Yeah, so I think in the latent space somewhere, it's linked that together, which is just...
Yeah.
So yeah.
Nice. Nicely done.
Yeah, thank you. So...
But none of them are in my office, right?
Yeah.
So it was able to do that even though actually only gave it images of me and Marvin.
Yeah, that's how impressive it is.
Okay.
Another thing I want to go over is how the strength of the LoRA impacts the image that you get, right? So I'm going to go over here.
What does strength mean in this sense?
So the strength of the LoRA is how much those LoRA weights impact the weights of the
You
network.
could literally multiply them by a smaller or bigger weighting factor to give them more or less influence over the underlying network weights. And that would mean it's essentially making the LoRA have more of an effect on the output or less of an effect on the output.
When I was doing my image generation, I wanted to make Mike Pound as Mike Wazowski, right? You know, standard stuff, right? But when I made it with a LoRA strength of 1, it comes out with Mike Wazowski. There's no Michael Pound in there, right?
This is the Monsters Inc. thing.
Yeah.
Monsters Inc. So what we had to do is increase the strength of the LoRA, so add more Mike in there, right? So this is strength of 1. If you do a strength of 1.5, suddenly it's starting to look a little bit more like Mike.
I mean, that's quite offensive, actually, looking at this. But sure.
But you'll notice the eyebrows are Mike's hair,
Okay.
which is really interesting. And it's given 2 eyes because Mike has 2 eyes. So now if we go to 2, we've gone back to 1 eye, but suddenly it's now got Mike's hair in there.
When you say 1.5 to out of what? Out of 10?
Out of infinite. But you'll get to a certain point where you'll realise that it you know, it's just too much, right? So 0, no cost.
It's already too much.
Yeah. 2.5, suddenly it looks
Now
like...
we're getting there.
Yeah, that's Mike.
Not in a good way.
Yeah, it's like if Mike put on green face paint and got like stung by a bee or something like that, right? So it's looking very cursed. So that's 2.5. What happens if we do 3? Oh
no.
Oh dear. What's happened
That's
here?
like a kind of spitting image puppet thing.
Yes, it is!
Yeah, we
Yes,
don't
it
want that.
is. So what I find really interesting about this is that the weights of Mike are influencing the network so much that it's almost forgotten how to make a human.
Also, how many lapel mics do I have on that image?
That down there is the mic that you wear for the video. But it's forgotten how to draw a microphone, so it just adds these dots in there going, yeah, that will do. And you'll see in the background, suddenly a window is starting to appear because that's the window from the office, right? So the strength of the mic LoRA is so strong that, you know, it's overpowering the network that learned how to draw a person.
Mike, we need to get out of this office more.
I know. I've always thought that.
And then if you do it even more, it looks like some abstract art.
It's broken now.
It's trying to draw something. It knows the colours, but it doesn't know how to draw a person. And
These tools are still very much a kind of hit and miss. You know, the prompting, the weights that you apply, the retraining that you do. There is no one solution, which I think is still interesting.
Yeah.
It's not been solved.
Yes, yeah. So you have to pick the right parameters for this, and then 4, 10.
Yeah, it's broken.
It's broken. No. So I'd say a strength of around 1 to 1.5 is pretty good, unless you're doing something like Mike Wazowski, then you need to up it a bit more. So we could go through each individual part, but we haven't got time. So I'm going to cut to the chase and just show you what MikeBot can do, right? So this is to be clear, a very cherry-picked video at MikeBot at its best. A lot of the time it will just generate nonsense. This entire thing is done automatically and done by AI. Open source, 20 images of Mike, and then about an hour of audio to get it crisp. This is all automatic, right? So we have here, MikeBot explains firewalls.
So today I want to talk about firewalls in computers. A firewall is a network security system that monitors and controls incoming and outgoing network traffic based on predetermined security rules. It acts as a barrier between a trusted area of the network and an untrusted one, like the internet, for example.
Your face went a bit off there, didn't it?
Look at the sleeve, look at the sleeve.
Sends out packets of data.
So you've got jumper on.
Sensitive information. A firewall checks these packets.
Now you've got white,
only allows them to
white shirt on.
Certain security rules. Think of it like the security guard.
And you're back to a black jumper.
So,
Magic.
benefits of using firewalls? For one, they help protect your computer.
You also notice you start going more and more red, like your Violet Beauregard from Willy
That's just the
Wonka.
aging process.
Data and systems. So make sure to turn on your firewall to keep your computer safe.
So, I mean, you know, putting aside the very peculiar nature of this video, obviously some things don't work, right? So the close change, this is because you're generating a video presumably in 4-second chunks.
Yes.
And when my hand is out of shot, it'll make up some new close. That kind of makes sense. Yeah. And, you know, my face changes a bit and stuff. But actually, given where we were a couple of years ago, this is very impressive. And Obviously, we're not going to be producing Computerphile videos anyway that are produced by AI, because I actually quite like talking to people about computers and would like to continue to do so. But it does make you think that for short clips in the media, on instant messaging, on social media, this is starting to become a bit more possible, even with pretty basic tools that we're using. I mean, I say they're basic tools, they're not, but it wasn't that complicated to get the pipeline running.
And this was done on my computer with an average GPU with 20 images. 20 images.
So, in this case, I'm doing a pretty benign video about firewalls, but of course that's not what you didn't need to script that. You could have scripted something a little bit more troubling.
Well, let's go on to what the closed source solutions can do.
A wild, untamed might.
So I've used a closed source software called Hedra to generate a video of Mike, which I'm going to use as leverage against him. So let's have a look at what I've done here.
Hello, Tony. Quick message about my favorite PhD student, Lewis. He is just simply the best student I have ever had the privilege of supervising. I want you to please promote him straight to a full professorship position and demote me back to a PhD student. Also, I want you to divert all of my grant money straight into his personal bank account. He needs it much more than I ever did. Excellent. Thank you very much. Michael P. out.
Michael P. out.
Was it Michael P. out?
Michael P. out, yeah.
Okay,
Michael P. out.
But I mean, the audio is better.
Yeah.
The video is better, right?
Yeah. And so now this is my office. Thank you, Mr. Pound, for giving me all your money. And that was all certified by the head of school.
Yeah, I'm sure he'll believe it.
Was the closed source one the same sort of 20 images? Yeah.
No, I just gave it one image of Mike. Literally, so here's the thing, with the closed source, you just need an image of someone. So you generate a new image with the LoRA, and then we pass that to the closed source, and then that with the pass that with the audio, and it's able to do the video with the lip syncing, all that completely done in an extremely realistic fashion.
This is a commercial tool now that we're using, but the point is this is now possible, and the open source tools will follow soon enough. We have to start thinking about the idea that in a few years' time we will be able to produce videos that look very, very convincing. Yes, we can already do that with a lot of effort, but it's not perhaps ubiquitous, but it will be. And then when it is, what do we do about that, right? Do we have some kind of ban on people using anyone else's images for anything? I mean, you have to think about all the different options, because you could make me say anything you wanted, and me saying, well, it's just AI, I didn't say that. Of course, it can work both ways. It gets very complicated very, very quickly.
Yeah, I was remembering we did a video in your garden talking about the Tom Cruise.
Yeah.
And at the time they had to have a similar looking person with similar hair. And
That's the thing. A few years ago, deepfakes were all the buzz, but you needed loads and loads of images for that, and even then it didn't work all the time, right? Well, this was 20 images, and the video model and the image generator, they do the heavy lifting for it. Creating fake videos of people was always possible, but you had to be a really high-class editor or visual effects artist and all that. To do it now, any old person can do it, right? Anyone. And all you need is just an image and some audio, and you can make anyone say anything, which is really quite scary.
It's Computerphile time. Shots clicking magic, editing